name's Ashley. Going to be talking about HTML5 games technology in 2018. Web technology, what do I do? I am founder of Scirra Limited. We make some game creation software called Construct 2, Construct 3. Construct 3 is our latest product. It's like a game editor for non-technical people, so you don't have to know how to program, you can just drag and drop and build a game. So we kind of describe it as a bit like PowerPoint for games. It's interesting, I think I've got an interesting perspective because we've moved from an entirely native tech stack to an entirely web tech stack. So Construct 3 is a browser-based editor, it runs in all major browsers, and all the games it makes are HTML5 as well, and so everything runs on lots of platforms. So what I want to talk about today is really technology, as ever, moves really quickly, and I think one of the problems with HTML5 is the perceptions like the reality of where it is today. Sometimes people still drag up this whole thing about Mark Zuckerberg describing HTML5 as a mistake. That was in 2012, over 5 years ago now, and of course on the internet that's like 50 internet years. Everything's changed completely since then. Yeah, another thing that people sometimes mention, we see people saying, oh, I don't want to use Construct 3 because JavaScript is slow, or sort of looking down on the technology like that. Really, JavaScript is now a super well-optimized language. The Duke compilers are really great. And actually, our JavaScript-based engine running in Chrome can beat some of our competitors who have native engines in some benchmarks. So it's competitive tech. So I just want to talk a little bit about, I've got 15 minutes, there's a big area, I could talk for hours about this, I'm going to try and compress it in. I'm going to talk a bit about the past 5 years, where we've come, some of the things which are happening with the technology now, and a quick view to the future and how things might develop over the next couple of years. Also, in case you get bored, this big guy is on every slide, so we can look at him. I've got some badges of him if you want, so that's where I help you with. Okay, so this is like an almost hilariously condensed version of 5 years of loads of web tech development. If any browser engineers are watching this, I apologize. There's just been an absolute ton of progress in things like the JavaScript language, CSS, all of this kind of stuff. But if you're making a HTML5 game, the key things are really technologies like WebGL and WebAudio are the two main pieces of the puzzle. WebGL, just a few years ago, was only supported on maybe 2/3 of all systems. Not quite good enough if you want a board game launch. It's now ubiquitous, along with WebAudio, Gamepad, full screen support. All major browsers now do all of these technologies. They're just everywhere, you can count on them being there, which is great. There's also been a lot of development in the browser engines. TurboPan is an entirely new JavaScript optimizer, which Google introduced in Chrome this year. Rewrote the whole thing from the ground up. It's way faster, it's much more optimizable for the future. Firefox Quantum came out recently, which is they've really redesigned some of the fundamental technology in the browser using very interestingly a new programming language called Rust. And this is much better at using multi-core and memory safety and things like that. All major browsers are now 64-bit by default, so you can use more memory. There's also performance, security, and reliability improvements with having a 64-bit browser. And just absolutely tons more. I could do a whole hour-long talk on this, but I'm going to move on. So what are the things that are happening in web technology at the moment? And there's some really interesting things in development. First of all, what's happening with WebGL? WebGL 1, which I mentioned earlier, is based on OpenGL ES2. That's quite a basic sort of reverse common denominator of graphics. It's ubiquitously supported these days. But the next step is WebGL 2, which is based on OpenGL ES3. It's a big and welcome improvement in the graphics capabilities and performance capabilities of graphics. So you can do a lot more of that. Obviously, it's not quite OpenGL 4.6 yet, but there's some interesting further developments which we'll talk about later. Chrome and Firefox support WebGL 2 already. Safari has it in preview, and Microsoft are sort of planning it for Edge. It looks likely that soon this will be widely supported as well, and there's also a hardware requirement, but I think ultimately it's inevitable this will become ubiquitously supported as well. And if you don't have WebGL 2, you can always fall back to WebGL 1. You've got that basic level of graphic capabilities there. Everyone wants their code to run faster, and the most, JavaScript has been getting faster non-stop for the past 5 years, but I think the most interesting development on this part is WebAssembly, which is derived from a technology called ASM.js, I think that's how you say it, which Mozilla invented, which is a way to basically compile C and C++ code to a sort of funny dialect of JavaScript, which is like bytecode, and the browser can optimize very well. But there's some issues with that, particularly around download size and the pass time of JavaScript. So WebAssembly is a proper binary executable bytecode format which all browsers now support, all major browsers already support it. It's a widely supported standard, and you can get very close to native performance with it, maybe 90% of native performance, and there's still ways that can be improved with technologies like SIMD and memory optimizations and things. So typically this is used for compiling existing C++ code bases to the web. We use it, we compile FFmpeg to WebAssembly for audio encoding in Construct 3. And this, I think this is the technology which is going to finally displace things like Flash, the old Netscape plugin model, and native client. These are sort of other proprietary browser plugins designed to run native code, but WebAssembly I really think is going to make all of that redundant. Don't use the, some of these technologies have had questionable benefits in the past. Some people are quite skeptical of Netscape plugins for good reason. WebAssembly is very different to all of these because it's standardized and it's developed by all major browsers collaboratively, so it's not just one vendor saying, oh, I want to do this. Everyone's already agreed on this, and there's lots of there's a bright future in that thing. So the demo people tend to get out here is this Epic Games Zen Garden demo. This is they compiled their C++ engine to WebAssembly, and it uses WebGL2 graphics, and you can see you can do some interesting things. Considering this is running in a browser and runs on all platforms, that's pretty cool, I think. So another thing which is happening in HTML5 games at the moment is a move to make a more app-like experience with your game. So obviously in the browser you type in the URL and the game loads up, and that's great. But on a desktop you want like an icon presenting an app, you want it in your start menu. On a mobile you want your home screen icon so you can run it like an app. And Chrome have really been leading the way with this. They've got this feature called Add to Desktop or Add to Home Screen, and this will add an icon on your device which will launch the app. And it gets rid of the address bar and all the browser UI, so it's pretty indistinguishable from a native app. And there's another technology called Service Worker, which is a replacement for App Cache, which allows you to reliably do offline support. So, of course, your Wi-Fi or 4G can drop out, or 3G or 2G, whatever you have, can all drop out, and the app will continue working. And one of the great things about using web technology for apps, it runs across all platforms are free: Mac, Linux, Chrome OS, Android, iOS, and there are no fees. And if compared to the apps, many app stores will take a 30% cut. It's none of that on the web, so it's quite a good benefit. If that's not enough, you can make actual apps using some frameworks such as Electron and NWJS. These are basically just the Chromium browser engine, which you bundle with your web content. Again, none of the browser UI like the address bar, it just looks and works like a native app. And this includes the Node.js API, so you can do things like full file system access, which you can't do with the browser for obvious security reasons. And then this allows you to distribute via other platforms like Steam, which expect you to have a native app instead of a link to a URL. And this is already out there. This is a game someone made with Construct 2 called The Next Penelope. There's nothing there which says, look, it's web technology. It's just, it looks like any other game and it'll play like any other game. So in fact, you might have already played some HTML5, some web technology-based games and not noticed because it's pretty hard to tell. Where are things going to go next in web technology? What's coming up in the next couple of years? And there's some really interesting, some things I'm really excited about. So WebGL ES3 is still a few years behind the latest desktop graphics capabilities. And the next big push in web technology is to sort of close the gap and catch up with the Vulkan, Metal, and DirectX 12 generation of APIs. if you're not familiar with these are a big break from the past. They're completely redesigned APIs, which don't have all the legacy craft of things like OpenGL, which came from the 90s. And they're so low level that you can make best use of the resources in the GPU. This is in the works. It's currently being standardized. They haven't even decided on the name yet, so this is probably a few years out. But this should help be a big jump up from WebGL, even WebGL2, and give you sort of a very modern set of graphics capabilities in the browser. And I'm told by engineers at Google and so on that work on WebGL is still continuing. They're not going to just abandon that. WebGL is good, and it still has its strengths as a sort of higher level API to work with, even though it's right WebGL. And another important thing is, obviously, for maximum performance, all modern devices are multi-core, and to make best use of the performance of the device, you need to be able to run multiple threads, one per core. Typically, JavaScript has been single-threaded. You have the main thread, which is a thread with access to the document, and that's only going to be able to max out one core, and it also has to contend with everything else the browser's doing. So a really important thing to do to get sort of jank-free performance and multi-core execution is this what's called Web Worker. The problem with Web Worker is it doesn't have too many APIs, it's missing access to the document, and it can be a challenge to move code over to that. One of the major things which makes it easier for games to move your code into a worker is a technology called off-screen canvas, which is nearly ready and should start coming out this year. And this allows you to render to WebGL, WebGL2, or the normal 2D canvas from a web worker. So this solves the graphics problem. You can run all your graphics code in the worker. Another thing which is coming is shared array buffer, which is sort of native grade shared memory for JavaScript, and will allow very high performance multi-threading. So you don't have to copy anything between threads. You can just write it to memory which both threads can see. If you've ever written multi-threaded code, this is a bit scary. You should have some trepidation about that. But the idea is that it creates the capabilities which the native tech has, which libraries and frameworks and things can be built onto, and give you this native grade multi-threading performance. And this will tie into WebAssembly as well. So your WebAssembly executables will be able to use these same technologies for high performance multi-threading from the browser. WebTech is starting to make some inroads into consoles, and the Universal Windows Platform (UWP) allows you to run WebTech games using JavaScript, WebGL, WebAudio on both Windows 10 desktops and on Xbox One. It's pretty exciting. They have the Xbox Creators Program and Idea at Xbox, which are good ways for indie developers to start getting involved in publishing. Nintendo had the Nintendo Web Framework on the Wii U, which I worked with a bit and had mixed results, I would say. I've not got anything on the Switch yet, but I'm hoping that with Nintendo and Sony, they'll start to see the benefits of this, because I think that the key benefit is if web technology is so good that it's 90 to 95% as good as native, why should you have to do an expensive port to your game to another technology? It should already be good enough. So as long as they have the capabilities to run a modern browser engine, that should work. And I think that something which is really cool is the most popular single board computer is the Raspberry Pi, but this one's an Asus Tinkerboard. The reason I call it out is the hardware is a bit better. It's £45, quad-core, 1.8 gigahertz processor, 2 gigs of RAM, and a GPU which can run WebGL2. So that's OpenGL ES3. It's probably not going to replace the next gaming rig, but I think it's really cool that the really sort of this represents the bottom end of tech, and it's actually quite good. So there's a good GPU in there, and it's good for running. You can run casual games, 2D games. It's good for hobbyists. Put it in an arcade cab, you've got something to play with. So I think that's really cool. And how am I doing for time? 5 minutes. Okay, I'm doing well. Yeah, I'm trying to blow through everything super quick. So, in conclusion, what I'm trying to highlight in this talk is that we've come a long way. The web platform has great momentum. There are thousands of engineers across all browser makers working really hard on pushing this forward. And now I think it's really serious tech. You can do heavy graphics work with native-like code development IDE into the browser, and it works really well. And I think it's further ahead than people think, especially the latest developments with WebAssembly, WebGL2, and with WebGPU on the horizon. There's some really, I think in a few years, we're 90% of the way there, and in a few years it will be indistinguishable. We'll have everything you need to compare to native tech in the browser. And in some areas, web tech already far exceeds what you can do with native, because this is truly the right one to run anywhere, which has been bandied around for decades, but it really has happened now. Our engine runs on Windows, Mac, Linux, Chrome OS, Android, and iOS, and likely any new ones which come along, because everyone has to have a web browser on their operating system. So I think people often look down on HTML5 because it's had a long way to come. In, say, 2011, 2012, it did have serious problems with things like performance and capabilities, but this is all solved. The new reality now is it's all there, and it's working great. And I think in the future, this might just change everything. It could upend the market, and maybe in the future we'll be using web tech, but who knows? And that's it for my talk. Thank you. Do I have time for questions? A couple of questions, anyone? Yeah?
Right, so Facebook introduced instant games at some point.
Sorry?
Facebook instant games, the ones you see on Messenger, are those HTML5?
I haven't looked into Facebook instant games a lot, so I'm not really qualified to answer, but I believe they are, so that's the best answer.
Because it's an interesting new platform, and since this is close to 90% close to native, it's kind of the right time to develop for that, I guess.
Yeah, I think there's opportunity there. Yeah.
Do you find memory overhead to be something of an issue? I know Electron gets a bad rep for it.
Yeah, that's a good point. Obviously, the browser still does have overhead, and there is some memory overhead to that. But I think that these days, when you have that little credit card size board I showed earlier has 2 gigabytes of memory, and if you're talking about another 50 megs of memory, 100 megs on top of that, I mean, yeah, it's something, but it's not the end of the world. And I think the benefits far outweigh the cost of that. It's interesting, one of the problems we had recently with people playing games in the browser is often they have browser add-ons like ad blockers, which use tons of memory, and this adds to like the overall memory use of the browser, and they compare that to a game not in the browser, and they say, oh look, it uses loads more memory. But this is something that using an Electron or an NWJS gets you further away from the overhead of the browser, because it's a really stripped down, just core browser engine.
Thanks.
Yeah.
Web AR has kind of been prototyped a little bit. What do you think about that? There are some companies like Euphoria trying to sit on top of AR Core, AR Kit, and so on. Do you think that will be unified in a browser at some point?
Yeah, I've seen that WebVR is a thing which is happening. I don't know an awful lot about it because ad products tend to be 2D based. But I think I've seen there is cross-browser support for WebVR, which again uses WebGL, WebGL2 for 3D rendering in stereo completely. So it's definitely developing, but again, I'm sorry, it's a bit outside my what I